All right, let's go over a recap of 11.2 in your book. Page starts on page 601. Get that on there, 601. Okay, basically in this lesson we learned three things: how to do the area for a triangle, a trapezoid, and a rhombus. And the area of a triangle, we have 1/2 base times height, where the base is one side of the triangle, and the height is the altitude that comes straight off of that side that's your base. In a trapezoid, it's 1/2 the height times the sum of the two bases. Well, the bottom of a trapezoid and the top of the trapezoid, the two parallel sides are your bases. Add them together. The height is the altitude from one of the vertexes straight down. And in the rhombus, 1/2, the area is equal to 1/2 the multiplication of the two diagonals. So you get diagonal 1, which is the long diagonal of a rhombus, and diagonal 2, which is the short diagonal. So both of those multiplied together times 1/2 equals the area of a rhombus. So let's use those in a couple problems. Let's say I'm given a quadrilateral. Let's not do it that way. I'm going to draw a little better. Here we go. Okay, kind of an oddball quadrilateral. Nothing meant to be perfect about this. If I draw a dotted line there, and I'm asked to find the area of this quadrilateral. I draw the dotted line right there, and I give that an altitude, and I give an altitude to there. I've now drawn basically that top half of that quadrilateral and the bottom half. If I add them together, that'll equal the area of the whole thing. So all I really have to do is calculate the area of two different triangles. And in this example, we're told that this middle line is 39 long. We're told that that height is 21 and that height is 20. So all we have to do is find the area of that top triangle. Well, the base is 39, 1/2 times the base of 39 times the height is 21 plus the area of this bottom triangle, 1/2 times the base, well, it's the same base, 39, one side of the triangle. The altitude of that triangle is 20, or the height, and that added together gives you the both. And if you add them, if you calculate that out, 409.5 plus 390, and our final answer is 799.5 units squared. All right, let's try number 2. What if I'm given a coordinate plane and a trapezoid that looks something like this? And I'm told that point T here is -3, 4, and point V is 3, 4, and point W is 6, -1, and point Z is -5, -1. And we're told asked to find the area. Well, if we're asked to find the area of a trapezoid, we need to know both bases, both parallel sides, and the height. So if I take a look at that, I'm going to draw the dotted line in there, and there's my height that I have to figure out. Well, since these are coordinate on a coordinate plane and I have ordered pairs for each one, I can figure out how far from here to here. Well, that's the change in the x-coordinate. So the change in the x-coordinate here, we went from -5 to 6. That happens to be 11. So we know that base 1, draw a line here, base 1 is equal to 11. Now let's figure out that top base. It goes from -3 to +3. Well, on a coordinate plane, that would be 6 units. So now we count this dotted line. Well, we're starting at 4, and we're going to -1 for the y value. So 4 down to 0 would be 4, plus 1 more would be a 5. So the height is equal to 5. So now all I have to do is plug those numbers into that equation, and let's write that all out. The area of a trapezoid is equal to 1/2 the height times base 1 plus base 2. And let's substitute in. The height is 5. The base is 11 plus 6, 6, which is 1/2 times 5 times 17. And if you figure that out, it equals 42.5 units squared. All right, now let's turn over and try the last page, the last problem. Last problem will be that we recap here with 3. Let's take a look at a rhombus. Okay, that's a rhombus on a coordinate plane with point E is equal to -1, 3. Point G is equal to 5, 3. Point F is equal to 2, 7. And point H is 2, -1. So, looking at our previous sheet, to do a rhombus, we need to know the sides of the two diagonals. Okay, so in this drawing, FH is one diagonal and EG is another. So how long are they? Well, F starts at y value of 7 and ends at y value of -1. So FH is 8 units long. E starts at -1 on the x scale and ends at 5. So 1 back to 0 and then 5 more, it gives me 6. So now I go back to my calculation for the area of a rhombus. 1/2 times 8 times 6. And that gives me 1/2 times 48, which gives me 24. And it's, once again, units squared, because it's an area. And that is a quick recap of this lesson.